Okay, I will be focusing on the core things that we need to remember. Please, I won't be going through all of it. If there's something we need to slow down on, please tell me. But otherwise, we learned this and we're just focusing on the important things. Okay, so the first important thing I want to be sure that you guys are comfortable with is your linear function, a straight line graph. And that we've learned since last year, y equals mx plus c. To be able to find that equation, you need to be able to find your gradient, okay? And you need to find your y-intercept. So the c value is your y-intercept. So as long as you've got a gradient and a point on the graph, you should be able to find the equation. So they've given you how you'd find the equation there in your course notes. So if you've got two coordinates, you can calculate it using your gradient formula. Okay, please make sure you're comfortable with that. If you know that there's two lines parallel, you can use the fact that those gradients will be equal to each other. And then if they're perpendicular to each other, they will multiply to give me -1. So guys, this is the theory. They will multiply to give me -1. But if the gradient of the first graph is 5/4, the gradient of the one perpendicular to that is always going to be flipped over, and then you change the sign. And it will be like that every single time, because I find sometimes children try to substitute into this formula, and it's okay, but it ends up wasting a lot of time. It's something you should be able to do in one step. I just want to show you, if I go 5/4 and I multiply it by -4/5, I'm going to get an answer of -20/20, which is -1. So every single time, the quick way of getting there, this is the theory. You need to know that to explain yourself about things being perpendicular. But all you have to do to actually get to the perpendicular gradient is you flip it over and you change the sign. Okay, so that's how you can find your gradient for the straight line equation. And they've given you an example. Here, I want us to focus on the examples where it's a special situation. So we're so used to always seeing y equals mx plus c that we start panicking with the really easy ones. And that's when we've got a vertical line or a horizontal line, which I'm sure will come up next to it. No, it won't. Okay, so we'll go back and focus on the vertical line first. So vertical line, your y value will always change, but your x value always stays the same. It doesn't matter where I go to on that line, the x value will stay the same. So the equation of a vertical line does not look like y equals mx plus c. You'll find the gradient is actually undefined. Okay, and it's just going to be x equal to a number. So please make sure you're okay with that and you don't panic when you get an undefined gradient. Okay, here's an example where they've used perpendicular. And here's the example of the horizontal line that I wanted to focus on. The horizontal line, you'll notice all the way along that line, your y value is going to stay the same. So it doesn't look like y equals mx plus c. It just looks like y equal to whatever y value you can find. So it's just y equals a number. Okay, and the reason is because your gradient there will be 0. Okay, so please, I want you to realize that the vertical line and the horizontal line, they don't look like y equals mx plus c. But they're nice, straightforward marks that you should be getting. So don't let yourself get confused. And then they've given you an example where you have to calculate the gradient. How would you get the c value if it's not given to you? You'd substitute in a point anywhere on that line. Not any point anywhere on the Cartesian plane, but on that line. And then you can solve for that c value. Okay, so that's basically your straight line graphs. As I said, I'm flying through them quickly so we can practice as much as we can for these graphs because there's lots of application to it. Okay, one of the new things you learned this year was a quadratic function or parabola. Your quadratic function will always look like, will always look like that. Okay, so that is your quadratic function. It's an x squared. Guys, it is very important to remember what the equation looks like, because if I get y equals 5x squared minus 7, if I get that as an equation, I need you to straight away look at that and go, that's going to give me a parabola, which is either going to be the happy face graph or the sad face graph. In this specific situation, because the x squared has a positive coefficient, it is the happy face graph. That's what they're talking about over here, the positive coefficient of the x squared. But guys, you need to recognize that, and that is part of your learning work. Maths does have learning work, okay? Things that you need to remember about this parabola is currently in grade 10, they have made it a very straightforward parabola. So you'll find that it's always going to have the q value there at the end. Do you see if I make my x 0, I'll just be left with the q. That is also going to be the y-intercept. Okay, so your q is going to be the y-intercept, that constant number at the end. So remember, the a and the q would normally have numbers. Your turning point is going to be the same place as that y-intercept. So your x value is 0, and then your q value. That's going to be your turning point. Your domain, you can see this graph has arrows on the end, and it's forever and ever getting wider and wider and wider. So if I think about my domain, which is all my x values, it's going to just carry on getting bigger in both directions. So it's absolutely every x value is an option. Okay, so that's why they said x is an element of reals. Okay, however, your range, you'll see if it's the sad face graph, the highest point is at that turning point. So it's never going to go higher than that, but it will go down forever. And for the smiley face, you can see it's got a minimum and it will go up forever. So here they've given you two situations. The one was where it was a minimum. That was when your A value was positive, okay? So that was for your smiley face graph and your sad face graph. Sorry, I know I'm saying smiley face, sad face, it's force of habit. The mathematical terms here are concave up and concave down. Okay. I don't know what it says in your course notes. I see here it says a P, but you'll see there is no P in my equation. It's supposed to be a Q. So if that is a P in your course notes, please, it's Q to infinity and negative infinity to Q. And then lastly, you can see it's symmetrical. So some symmetry is, remember, where you can cut something down the middle. It doesn't have to go straight down. It could go across in the middle, but both sides would be exactly the same. It's like a mirror reflection, okay? So you will always have an axis of symmetry for a parabola, where you could cut the graph in half. Sorry, that's a very bad straight line. And you can see the two curves are exactly the same. They'd fall on top of each other if I were to fold it. Okay, and that is always your y-axis, and the equation for the y-axis is x equal to 0. So that is the y-axis. It's the same thing, but make sure if they ask you about it, if they've asked for an equation, please give them x equals 0. So that's what we need to know about our parabola. It is the learning work. And then there's just a few techniques that we're going to run through. So finding the equation of the parabola, it depends what information they give us. So remember here, the A and the Q value can be very useful. If you've given us the turning point, you can substitute that into the Q straight away. Because remember, there's lots of stuff to remember. Okay, your turning point was from the Q value. So that's your very first step. And then the same as we did with the straight line, you substitute another point from the graph and solve for A. Okay, so you're always going to solve for that A value that's missing. That's if you need to find the equation. There is another format that if they haven't given you the turning point that you might have to use to find the equation. And that is this fancy one that they say when they've given you the roots. Guys, we haven't all of a sudden changed to life sciences. Okay, roots is the same as x-intercepts. Okay, so if they're talking about the roots, they're talking about the x-intercepts. So do you see here, I don't know what the turning point is, but I do have my two x-intercepts. And remember, even if they've given me one of the x-intercepts, these are going to reflect over this line y equal, so this y-axis, x equals 0. So they're always, in grade 10, should I say, they're always going to have the negative for the one side and the positive for the other side, but they're the same numbers, okay, because they're the same distance away from the y-axis. So you would substitute those in for your roots, okay? Roots and x-intercepts are the same thing. So if you have a look here, they've substituted the -4 and the 4. Do you see here, we've got a double negative, so be careful with that. They multiply that out, and then they again, they're going to have to solve for a. So that step hasn't changed. It's just the starting step and the format that has changed. Sketching the graph, you use the turning point, which remember was that constant term at the end. You calculate your x-intercepts, guys, and the beauty about x-intercepts. Who can tell me how to find your x-intercept? Type it in the chat. I need to make sure you guys are still awake and I haven't put you to sleep yet. What do you do to find x-intercepts? And the same, it's going to be the same for every single graph. So if you know how to find the x-intercept anywhere, thank you, Emma. Thank you, Natalia. Yes, Dimple. Yes, Lamise. Okay, find your x-intercepts. Sorry, I have a feeling I might have said yes and I was, no, you're all right. Okay, so your x-intercept, you're going to make y equal to 0. And guys, that is the same for every single graph. If you need to sketch the graph, you find your x-intercepts by making y equal to 0. Just want to make sure you guys know why. Yeah, making y equal to 0, why? Guys, your x-intercept is going to be along this line, along your x-axis. This is where the graph cuts the x-axis. Okay, so that's the horizontal line that I was talking about earlier. And remember, for a horizontal line, your y value is going to be the same all the time. And on this x-axis, we know that the y value has to be 0. So whenever you're looking for a point on the x-axis, straight away you know that y is 0. Okay, that's the reason why. And please make sure you know what shape to expect because it helps you to spot errors. Okay, we're going to run through all the different shapes together at the end. Okay, so here they've given an example, which I'm going to quickly flip through. I think you guys have seen it in your in-depth sessions, and you do have it there in your course notes, and we will get to hopefully practice everything before the end. Okay. The next one is a hyperbola. Now, hyperbola has two different types of shapes. The first thing is it's two curves. Okay, so it looks like two graphs, but it's only one. Okay, and the first shape is basically saying that you got a curve in the top right-hand side and a curve in the bottom left-hand side. Okay, that's the first shape that you could get. The other shape is in the top left and bottom right. Okay, there's two curves. And how do you know which one it's going to be? You look at the value on top of the x. So there'll always be a fraction. Again, please make sure you know what format we are looking at. So that guy with the x in the denominator will always give you a hyperbola, which is two curves. And if the fraction, so we focus on the fraction, if the fraction part is positive, do you see here the positive? That's when we know it's top right and bottom left. And when the fraction is negative, that's when we know it's the other two sections. Okay, we will always have asymptotes here. So now an asymptote is something that the graph cannot cross. And the easiest one, as the equation stands to explain, is probably this y equals a over x plus q. Do you agree if I made the x value equal to 0, I would land up with y equal to a over 0 plus q. It doesn't matter what the a and the q is. What is the problem with that x being equal to 0? Type it in the chat. What is the problem with that x value being equal to 0? Undefined, yes. Thank you, Nazar. Thank you, Kingiwe. Thank you, Lamise. Okay. It is going to be undefined. So if it's undefined, we literally cannot have a value on there. Okay. Be careful, guys. Undefined means there is no definition. Non-real means it's a different type of number. So there are things that are defined that are non-real. So it's not quite the same thing. I can't imagine that necessarily coming up in a test type question that would be an issue, but it could. So just be aware that undefined is different. So if it's undefined, we land up with what we call asymptotes. Okay. Your asymptote is always going to be at x equal to 0 and y equal to 0. Except for the fact, no, it's not going to be always at y equal to 0. Sorry, guys. This is going to be at y equals to that q value. Okay. So for grade 10, you've got this format of the equation. In this format of the equation, a over x plus q, in this format of the equation, your x equal to 0 is always going to be the issue. So that's going to be your first asymptote, x equal to 0, which is your y-axis. The other one is y equal to q. So it's whatever this q value is at the end. So if there is no q value, it'll be y equal to 0. But if there is a q value, your graph moves up and down and your asymptote moves with it. And you need to know these asymptotes. That's very important. The other thing that they like asking about with these graphs is the axis of symmetry. Now, your axis of symmetry, I'm going to draw them in for these graphs. I'm going to try and draw as the blue lines going across diagonally. Those would be axes of symmetry. And you can see that in this situation, we've actually got two axes of symmetry. In the parabola, we only had one. Okay. Doesn't matter which shape of the graph it is. We've only got two axes of symmetry, not to be confused with the asymptote. And I want you to notice those axes of symmetry always go through one specific point. And that point is where your x and y axis cross over. Okay, so now, where your asymptotes cross over, not your x and y axis. And I just said earlier that one of your asymptotes is always going to be x equal to 0 while you've got this format of the graph in grade 10. So what you need to do is that q value, your y-intercept, is always going to be the same as your q value from your graph, because that is where your horizontal asymptote will cross over. Your gradient is always the same. For the positive graph, for the positive straight line, your gradient will always be a 1. And for the negative, it's always going to be a -1. So that, again, that is not changing. So it's always going to be 1 or -1 for your gradients. Okay. So if they ask for the positive axis of symmetry, you know your gradient's 1. If they want the negative, it's going to be -1. And then your y-intercept is the same as that q value. Okay, so those are the things that you need to learn for your hyperbola. Sketching the graphs, filling your asymptotes first, because you know you're not allowed to cross over those. Determine your x-intercepts, making y equal to 0. And then make sure you know, is it the one in the top right? So make sure you know your shape. Is it going to be that guy? Or is it going to be this guy? Okay, make sure you've got the right shape because it helps to make sure you don't make any mistakes. This last one, use the table method to plot at least 3 other points. Guys, remember your table method is you choose any x values and you substitute them into the equation to get the matching y values. Okay. The most important points are the intercepts and the asymptotes and the shape. If they want additional points, they will usually specify it in the question. Okay, so pay attention to the question. If you know what your curve looks like, you'll be fine just sketching the curve. If you don't know what your curve looks like, then please find as many points to make sure you get your curve correct. Okay, so here's an example with the sketching. They found the asymptotes first, and then this is the table method. You choose your X values. If you are going to use this to help you with your shape, I recommend to use factors of the numerator. Okay, so remember your equation here, there's a numerator. Use factors just because then you don't get fractions. Okay, it's not always possible, but if you are going to do those tables to get extra points to plot, I would recommend that. Here's another example. Draw in your asymptotes first, and then you can get additional points. Next one is determining the equation. So remember, this guy here came from your asymptote, that horizontal asymptote. So the minute they've told you that that horizontal asymptote is 2, that's where I'm going to get that Q value. That's 1 mark straight away, just because I learned that my horizontal asymptote goes into that position. Then, like your other equations, you substitute in a coordinate and you solve. Okay, so everything, there's like a piece of information that you get, and then the next piece of information, you have to substitute a point and solve. It's the same for all of the graphs. They might look different. Okay, next one, last one, exponential graph. So I'm flying through this and I'm trying to make sure that I cover everything that I wanted to go through with you. Okay, so your exponential graph has 4 different shapes. I know it looks like 8 here, but they're just showing you as it moves up or down. So the one shape is where it's going up. Okay, you can see there's an asymptote underneath it and it's going up, it's increasing. The next shape, the asymptote's also underneath it, but it is decreasing. Okay, so these are the first 2 shapes. So they've just given you 2 examples of every single shape. The next 2 shapes, it's been reflected over the asymptote. So this reflection over the asymptote will happen. So the only time the asymptote is on top is again when there's a negative. So the negative all the way in the front, that's what will make the asymptote on top. This guy only has 1 asymptote. You'll see there's only 1 asymptote, y equals q. Okay, so this asymptote will be on top and it's just been reflected over. So if it was an increasing graph originally, which happens when you've got a value bigger than 1 in your base. Remember, this is an exponential. It means the x is in the exponent. So the base is the thing underneath the exponent, that big number sort of underneath the exponent. If that's bigger than 1, you get an increasing graph. But the minute you put a negative in front of it, do you see it flips over and becomes decreasing? It reflects over. Okay, so if you make sure you understand those shapes and then the negative reflects it over, you're fine. This one here is decreasing. That is when the base was a fraction between 0 and 1. Okay, so that's going to get smaller and smaller every single time. But if you put a negative in front, it flips over, it goes underneath the asymptote, and you'll see there it is increasing. Okay, so again, make sure you're comfortable with all those shapes. Sketching the graphs, put in your asymptote first. Calculate any y or x intercepts. So I made sure we could remember what to do for the x-intercepts. So the x-intercepts, we made y equals to 0. How do we find our y-intercepts? Type it in the chat. How do we find our y-intercepts? Yes, Emma. Yes, Nazaha. Awesome. Okay, making x equal to 0. Okay, that's how you'd find your y-intercept, and it's the same for all your graphs. Determine the shape. Make sure you know what it's going to look like. And then again, the table method, this is if it is needed. So that if you need extra points, so one, they've either asked you for extra points, or you do not have enough information to figure out how to draw your curve. That is when you need extra points, and that is when you use your table method. Remember, your table method is you choosing X values. So they've given us an example. You can see the table method, they've chosen some X values and they substituted in to help them with that shape. Okay, if you knew what the shape was going to look like, so if you knew it was going to be increasing, you would just draw that curve, okay, unless they ask for an extra point. Here's another example where it was a decreasing graph. Okay, notice they take note of what it's going to look like before they did the table. And then if you need to find the equation, remember your asymptote is your starting point. So that Q value at the end was your asymptote. And then here they've given you, sometimes they ask you for more than one thing. If you need to get A and B, please start. They should have two coordinates. So this can be a little bit trickier. Start by substituting in the y-intercept. Okay, so if you've got the y-intercept, do this one first, and then you substitute in the other point. And I'll show you why, because if we've got, okay, and we've been told, sorry, we've done our asymptote, so we know our asymptote, for example, is 3. Guys, so obviously you'd look at the question. If I substitute my y-intercept, remember your y-intercept was where x was equal to 0. So that's going to give me y equals a times b to the power of 0 plus 3. And whatever the y-intercept is, so sorry, the y-intercept could have been, I don't know, -4. I don't know, I made this up. Do you see that that b is going to fall away because anything to the power of 0 is 1? We reminded ourselves of that in our algebra on Monday. Okay, so you'd land up with just -4 is equal to a plus 3. That is why they tell you to substitute the y-intercept first. Okay, but pay attention to what they've given you in the question. And there is an example, and then I think I want to jump to the questions and memos. Yes, okay. So let's go to the questions and memos. We'll come back to various applications after the break. We're going to just practice a little bit before that. Question 4.1, make sure you've all got that in front of you. We're going to read the question first, and then from there, we will have a look at what they're actually asking us for, and I'm hoping I'm going to get volunteers. So it says, sketch below the graphs of f of x equal to ax squared plus q. So that's usually how they ask the question when you're going to have to figure out the equation. So they give you the equation, but without the numbers, okay? You can see here for the g of x, they have given us the numbers. So that one we're not going to have to figure out. A and B are x-intercepts of f. Remind me again, what is so special about the x-intercepts? Remind me again, everybody, what is so special about the x-intercepts? Y is equal to 0. So straight away at these 2 points, A and B, I might not know the coordinates, guys, but I know that my y value is 0. So I don't know what the x is, but I know the y value is 0. And that's why they told you that. The graphs intersect at A, okay? So A is a point where on both of the graphs, that's why that's important. They've given you the coordinates E, and they've said that that lies on F. So I underlined F with blue, so we'll try and keep our colors the same. Okay, C is the turning point. So remember, turning point is a very useful thing because your turning point helps you with your equation. So that's why they've told you that. And D is the y-intercept of G. So they've told us that we've got a y-intercept over there as well. Okay. So the first thing that they've asked me is they've asked me for the coordinates of D. Who's willing to help me with question A? Anybody willing to help me with question A? No. Okay, great. So then you guys are going to be participating in the chat. Okay, so Faith, can you unmute, or are you going to do it in the chat with me? Can you unmute? Okay, great. Okay, guys, so we're going to be doing this together then. All of us are doing it. Please don't just watch these sections. These sections are your practice times. Okay, let's have a look at question A. Okay, it says write down the coordinates of D. Now you'll see I've given you a hint there. Faith and everybody, you're all doing this with me because I'm using the color green and I've highlighted under the equation for G of X in green. So it's kind of a hint that we're going to use G of X. Why did I choose G of X equation instead of F of X's equation? Type in the chat because you guys don't want to unmute. Okay, I've got exponential asymptote graph. Okay, so the reason why I chose G of X is because this point D, which is the first question they asked, is on the G graph. Okay. And what is special about D? They told us that D is the y-intercept. Awesome. I'm so glad to see you guys still participating in the chat. Okay. So what is special about a y-intercept? Yes, Faith, brilliant. Yes, Emma and Dimple. Okay, so I'm writing this in a different format. You'll see the only thing that I changed, and I'm doing this because I know this notation is still new to you guys. They use it all the way to matric though. The G of X is the same as Y. So I want you to realize that. D is the y-intercept, and you guys have all said X is equal to 0. So that means I'm going to use this equation and make the X equal to 0. And anything to the power of 0 is what? Type it in the chat. Anything to the power of 0. Perfect. Brilliant. So glad to see you guys are all listening. Okay. So I get y is equal to 1 minus 4. And that gives me what answer? Yes, guys, and remember that we can all direct message if you want, because that way you're not giving everybody else the answers as well. I see there was a change in your answer there, Faith. I hope you're good with that and you're happy. 1 minus 4 is minus 3. And whenever you've worked something out, please fill it in on your diagram. Okay. The next thing they asked us about is the range. So this was number 1. And now number 2, they asked us about the range of G. So I'm still looking at the green guy. Now this is the next thing that everybody seems to struggle with. Okay. So first of all, there's 2 things. They're range and domain. They're very similar. The range is asking for Y values and the domain is asking for X values. Okay. So when I'm talking about the range, I'm the Lone Ranger. And this is my domain. So if I'm talking about the range, I'm looking for the Y values. Do you see I'm going up and down when I say that I'm the Lone Ranger? Okay. So that means I want to see how my graph goes in this direction. So always start from your smallest value. And in this direction, do you agree the smallest value is at the bottom? Okay. So I need to have a look. I'm looking at one graph in particular. I'm specifically looking at G and I'm trying to trace it, but it is a little bit tricky. Okay. And I want to see the lowest point it's ever going to be. I know I'm talking about Y values. The lowest point it's ever going to be. And it's a little bit tricky because it doesn't actually reach a point. It carries on forever. But there is a place that it doesn't go lower than. Okay. So yes, Tato, you definitely got the whole answer correct there. Okay, so this asymptote, do you agree my graph cannot cross over it? So this is where that learning work comes in because they didn't tell us what the value of the asymptote was. So please, let's go back to the equation. There should be something in this equation that tells you what that asymptote is going to be. So what's the value or what's the equation of that asymptote? It's a horizontal line. What is the equation of that asymptote? Okay, I want an equation, not just the value. Okay, and I want specifically this one. So not the rule. So yes, your asymptote is going to come from the Q value. So for this one specifically, it's y equals -4. Okay, y equals -4 is my asymptote. Actually, I'm going to write it on the graph there. Okay, are we all happy with that? Please don't use your P's and Q's. You must remember a horizontal line is going to be y equals, vertical line, x equals. Okay, the P's and Q's are the variables that we use when we don't know the values. Okay, it's not an official representation on your graph. Okay, so y equals -4. So now what's the lowest that that graph will ever be able to possibly get to, and will it ever actually reach there? So what's the lowest? I think I saw a lot of you doing that. Okay, it can't go lower than that asymptote. So the lowest it's going to be is -4. Brilliant. But is it ever going to reach the -4? Is it ever going to reach the -4? Okay, so if it's not going to reach there, I've got two choices. I've got either square brackets or round brackets. Which one would I use? If it's never going to reach there, would I use the square brackets or the round? Brilliant. Checks, you guys rocking this stuff. Okay, so y is element of -4. That's the smallest value. And then if I look, remember now I'm going up. Remember your graph has an arrow on it. How high is that graph going to get? It's going to carry on up and up and up to infinity and beyond. Brilliant. Okay, so from -4 to oh, that's a very horrible infinity. We'll try to draw it that one again. To infinity. Okay, now infinity will always get a round bracket, and I'm going to tell you why. Because it's not an actual value. You can't be equal to infinity because it just is this concept of carrying on forever. It's not a value, so you can't be equal to it, and that's why we use a round bracket always for infinity. Infinity will always, always, always get a round bracket. Are we all happy with question A? If there's any questions, now is your chance to ask. If there's anything you did not like about question A, now is your chance to ask. Otherwise, we're moving on to question 4. Okay, so I've been asked about the order of the numbers. Guys, this is something we call interval notation. Okay, and interval notation has to always be written from smallest to biggest. Okay, so I'm going to ask you, would you rather have a balance on your bank account of -4 Rand, or would you rather have a balance that is so big that they don't even know what value to write? I would rather have the balance of infinity, yes. So that means infinity is bigger than -4. I know infinity is not an actual number. So you always write from smallest to biggest. That's why we started at the bottom and we went up to the top. Okay, so the smallest value was -4 going up to infinity. If it had been negative infinity, we would have done it the other way around. Okay, so just be aware of it. If the graph had been going down, okay, if the graph had looked like that, this orange graph that I've just drawn in, and it was going down, then you would have gone from negative infinity to -4, and you would have done it the other way around. Okay, guys, that is just one format of notation. And other thing I've been asked is, can we use the other notation? I find that most children cope better with interval notation, which is why I use that. But absolutely, the inequalities, or the very unmathematical term, the crocodile mouths, you're more than welcome to do. And that is y greater than -4. So both of those are saying exactly the same thing. It's just two different notations. And yes, you are allowed to choose. But please be comfortable with both notations. And we are now going to answer question B. Okay, so question B is now asking for the coordinates of A is the first question. Okay, I'm not giving you hints with colors anymore. You can see I've started with a brand new color. What is so special about A? What is so special about A? Type it in the chat, tell me. Okay, the Y value is going to be 0. I've been asked, can we do simultaneous equations? Simultaneous equations, that is one of the reasons it's special, and Natalia spotted that as well. It is also the point of intersection for both graphs. But I want us to just look, all of these things you need to consider, but let's have a look at the equations we've got. Do you see I actually don't have the equation of the other graph? Okay, so if I had both equations, yes, definitely the point of intersection. But the fact that it's an x-intercept means that y is equal to 0. Okay, which graph is it an x-intercept for? Which graph is it an x-intercept for? Okay, we've got two graphs. We've got an F graph and we've got a G graph. Okay, it's an x-intercept for both of them, guys. But if we have a look at the equations that they've given me, we have a look at the equations that they've given me, only the one equation I've actually got. So the most useful graph to use here would be to use g of x. So if we need the coordinates of A, you guys told me that that's so special because it's an x-intercept, which means y is equal to 0. So what are we going to have here? We're going to have 0 is equal to a half to the power of x minus 4. Okay, so now let's see if we can remember what we learned about our exponential equations in algebra on Monday. Okay, so the first thing I have to do to try and get x on its own. What is the first thing I have to do to get x on its own? Okay, thank you, Natalia. We're going to move the 4 over. Okay, you need to get that power, the thing with the x, it needs to be on its own. If we did have like terms, absolutely we would group our like terms as well. But we didn't have any like terms, so we're just now trying to get the x on its own. And now for me to solve exponential graphs, exponential equations, I need my bases to be the same. Okay, so the next thing is I need both of these to be written as the same number to the power of something. So what base can I use for both of these numbers on the left and the right? Brilliant, Emma. Yes, Natalia. Yes, Kopotso. Okay, so this is going to become 2 squared. And tell me if you guys are okay with what I'm writing on the right-hand side. Is there anybody who's unhappy, should I say, rather than are you okay? If you're unhappy with what I just wrote on the right-hand side, let me know. Okay, and then I see that that means now I've got a power to a power, so that simplifies as 2 to the negative x. Once your bases are the same on both sides, I can just make the exponents equal. So that means x is negative 2. But they asked me for coordinates, so I'm not done. Please type in the chat. What are the coordinates of A? Type in the chat. What are the coordinates of A? Okay, I have some people who I think are forgetting the negative or typing so fast. I hope it's just because you're forgetting the negative or typing so fast. A is negative 2, 0. Make sure that the x value goes first. It's okay. I'm glad that we've got so much excitement. Well done, everybody. So then we go and put it here at our graph so that we know that we've worked that out. The next thing they want is the values of A and Q. So now they are asking me to get that equation. Okay. So if it's a parabola, what's the first thing I'm going to do to try and get that equation? I've got two methods to get the equation of a parabola. The one, I need the turning point because that will be my Q value. Okay, so method one is your turning point, which I don't know about you guys, but they haven't given it to us. Method two is actually a different format of the equation. Remember, it looks like this: x minus root 1 and x minus root 2. Okay, we are going to have to use the other points that we've got on our equation, the 1 and the 3 and the negative 2 possibly. Intercept, yes, Emma, that's the intercept method. We're going to use method 2 using our x-intercepts. But now I'm a little bit panicked. Guys, I've only got one x-intercept. I've got the coordinates of A. I do not have the coordinates of B. What would the coordinates of B be if I want to use the intercept method? Okay, great. Guys, remember this thing is symmetrical. So if the A is a negative 2, automatically you know that the B is going to be a positive 2. So I do have both of my intercepts. So we're going to use that method there. We're going to go y is equal to A, x minus negative 2. Remember the double negative. And then x minus the positive 2. You could skip this step if you want. And then I'm going to multiply that out. And that's what I've got at this point. Okay, then I was asked earlier, can we not use the random point, I think was the word that they used, the random point E, the 1, 3. And yes, it is on that graph, so we can use that. So my y value is going to become 3. And my x value is going to become 1. And when I do all of that, I should get an answer of, what's my A value going to be? Type it in the chat. Brilliant, Dimple. Okay, be careful. This is attached the A times by that bracket. So when you work out what's in the brackets, to move it over, you're going to divide. Yes, Natalia. So I'm going to show the steps here. We've got 1 squared minus 4, which is going to give me negative 3. Oh, sorry, Natalia, careful of your sign. Yes, Emma, yes, Nazaha. Okay, divide both sides by negative 3. And you're going to get A is equal to negative 1. Which means I can go back to that equation and y is equal to negative 1 x squared minus 4, which is equal to negative x squared plus 4. Okay, that is the equation. You've got the A value and you've got the Q value. Please make sure you answer the question. We already told them what A was, so please make sure you tell them that Q is equal to 4. Because we've now multiplied it out. Okay. If there's any questions on question B, now is your time to ask. Otherwise, we're moving on to question C. Any questions on question B? Now's the time to ask. Guys, remember, whenever you've worked something out, please add it to your diagram so that you don't forget. So I'm going to write your y equals negative x squared plus 4. And that also tells me that the C value up there is going to be a 4. Okay, so we're all good with that one. Question C says, determine the length of CD. Okay, so now these are application questions. Yes, thank you, Tato. Thank you, Dimple. Thank you, Emma. And we haven't gone through all the application stuff, which we will do just now. But I do think some of this application we're good with, so we can start practicing it already. Okay, guys, if you're asking for the length of a vertical line, I'm going to remind you now. It is in your course notes. A vertical line, basically it's not moving diagonally at all. It's not moving sideways. So you always take your biggest value minus your smallest value. So it's going to be your biggest, if you were going up and down, your biggest y value minus the smallest y value. Okay. The only reason why I'm saying biggest minus smallest is because then I will get a positive value. And if I'm talking about a length, guys, distance is always positive. There is nobody in the world who has ever broken the record for the negative 100 meter race at the Olympics because it doesn't exist. Distance is positive. Okay. So it's your biggest y minus your smallest y when we're talking about a line that is vertical. If you're talking about a line that is horizontal, it would be the biggest x minus the smallest x. Okay. And again, the biggest one will always be on the right and the smallest one will always be on the left. So how would we get the answer for the length of CD? That would give us 7 units. Are you all happy with where that 7 comes from? Please ask me if you don't know. Okay, we're doing question C. They now want the equation of the line, and this is our last question before our break. The equation of a straight line through A and D. Okay, so now please remember we've got the coordinates of A. I know I've just written a -2 there, but we know the full coordinate is -2, 0. And for D, the full coordinate is 0, -3. Okay, and now we're talking about the equation of a straight line. So this is C number 2. First thing I need to do is get the gradient. This is y equals mx plus c. So I want you all to type in the gradient. And if you don't know how to do the gradient, then please tell me, ma'am, I don't know what to do, but I'd like you to calculate the gradient for the line AD. The gradient for the line AD. Thank you, Tato. Thank you, Dimple. Thank you, Emma. I'm going to tell all of you, though, please make sure you've got your signs correct. A good way to tell is, remember, a line that's going down will always be negative. A line that is going up will always be positive. And when we say up and down, we're going from left to right. So please make sure you got your signs right. Thank you, Faith. Okay. Thank you, Natalia. Okay, so not everybody's answers are correct, but we definitely, I think, on the right track, guys. Remember, your formula for your gradient is y2 minus y1 over x2 minus x1. So you've got to use the coordinates that we've got. So I'm using the coordinates for D and the coordinates for A. It doesn't matter which one you start with, as long as you keep with that one. So if I subtract my y values, I'm going to go 0 minus -3. And then I'm going to go -2 minus 0. And if we work that out, we're going to get a -3 over 2. The 3 on top becomes positive, but the 2 at the bottom stays negative. That is my gradient. Okay, do I know the y-intercept of the line AD? Do I know the y-intercept of the line AD? Thank you, Tato. Okay, perfectly correct. I asked a yes or no question. Let me say, what is the y-intercept of the line AD? Thank you, guys. What is the y-intercept of the line AD? Okay, brilliant. Well done, guys. It's -3. And that now gives me enough information for my equation. So write out the equation in the chat, please. Write out the equation in the chat. We worked out our gradient. We worked out our y-intercept. And Tato, thank you for the answer again. I appreciate it. Yes, thank you, Emma. Okay. Again, if there's something you don't like about it, this is the time to ask. If there's something you don't know where I got it from, this is the time to ask. You can ask me privately in the chat if you are shy, but I promise you, you're not alone. And you can also unmute and ask me if it's too difficult to chat. Brilliant. You guys are rock stars. Okay, guys, we're going to go back to the course notes and we're going to have a look at the various applications now functions. Okay, so we've done all the theory, the straightforward theory. Distance I have already discussed with you. It is quite straightforward. I think the worst distance could be if they asked for a slanted distance. So we have spoken about the vertical distance. Okay, we have spoken about a vertical distance, which is going straight up and down, or a horizontal distance going straight across. Okay, a maximum distance or slanted distance. I want to first of all start with the slanted distance. This could be mixed with your analytical geometry, which you will be doing later in your revision sessions. But you should know that distance formula is square root of x2 minus x1 all squared plus y2 minus y1 all squared. Okay, so if we asked you for a slanted distance, you could actually do that as long as you got the coordinates on the other end, but you would need both the x value and the y value. Okay, whereas with the verticals, we only need the y values. Horizontals, we only need the x values. Okay, this maximum distance thing, I don't know, please raise your hands if your teachers have taught you how to complete the square. Please raise your hands if your teachers have taught you how to complete the square. Okay, that is grade 11 content. So I'm going to just cross that guy out there. Okay, and the vertical distance between graphs is what they're talking about here with the maximum distance. So the first thing you would do is you would take this top graph minus the bottom graph. This is something I would call a level 4 question currently while you guys are in grade 10. So this is just for interest. You take your top graph minus your bottom graph. This gives you another expression. So it basically gives you a new expression. Okay, but it would probably be quadratic. And you guys know what a quadratic looks like. It's your parabolas. Okay, it's concave up, which is a smiley face, or concave down, which is a sad face. So if they were asking for a maximum distance, this would give you a new expression that would give you a concave down graph. And do you see that right at the top there, that would be a maximum value. So this is a very fancy way for you to get that new expression. And then step 2, you're going to calculate what that turning point is, because that would be the maximum it could ever be. Okay, so that's the state, the maximum distance. And I'm going to cross out that line underneath because that was for completing the square. But for you guys, you would not be completing the square. You just need to find that maximum value right at the top. And that would be a level 4 question. Okay. So that's the distance. The next thing we've got to look at is points of intersection. Guys, we did this on Monday as well. Basically, you make the 2 equations equal to each other. This is the same as your simultaneous equations. Okay, the only difference is in simultaneous equations, you normally need to make y equals on one of your equations. But remember, f of x does represent y and g of x does represent y. So normally your equations are already in that format. Okay, so that's usually the case already for your equations. That's why they've just said here, you make them equal to each other. But it is the same as your simultaneous equations, and you solve the point of intersection. It came up as a suggestion earlier. Okay, obviously this is only helpful if you have both equations. Okay. So then you solve for x, you substitute back and get y. Decreasing and increasing, please, I want you to realize that we read from left to right. Now, I know there are some languages that don't, but we are writing maths in English and or Afrikaans. I don't think South Africa's yet offering it in any other language. But all the languages in South Africa, all 11 languages, we read from left to right. So it doesn't matter how you draw the graph. From left to right, do you see that this part is going down? So we call it decreasing. That part is going down, we call it decreasing. The other part that I haven't highlighted from left to right is going up, and that's where it's increasing. Okay, they often ask questions on that. Then notation, we've already touched on the fact that when I'm talking about f of x equals x squared plus 2, that is the same as saying y equals x squared plus 2. And the reason why that's important to understand is because what they're going to be asking a lot of now is they ask, where is f of x greater than 0? The reason why they use notation f of x, because remember our last question, we had 2 graphs on our picture. So you need to know which graph they're talking about. So that's why they say f of x. So you know they're talking about the graph of f, but they're asking where your y values are greater than 0. And on any Cartesian plane, your y values are positive above the x-axis. So here's my x-axis, and you can see in both of these examples, they've shaded above the x-axis. Okay, so that's what they're asking for. But then they will always ask for which x values does that happen. So you first look at your y values, and we will be doing some of those immediately after this. You first look at your y values, and once you know which section you're talking about, like they've shaded in here, your answer is going to be in terms of x. So your answer is in terms of x. So you don't look at the x's to begin with, because the question, they're asking about y, then you answer with your x's. Okay, then obviously f of x less than 0, that's underneath the graph. They sometimes ask the 2 graphs combined, which is a tricky one. So they've multiplied them. You know, if you multiply values and it has to give me a negative answer, less than or equal to 0, that means the 1 has to be positive and the 1 has to be a negative. So basically 1's above and 1's below. When they're comparing the graphs, they're talking about when is the one graph above or below the other. And lastly, when they're equal, that is the point of intersection. They like asking those questions. I can almost guarantee that you're going to get at least one of them. You won't get more than 2 though, I don't think. So I wouldn't panic, but you will get one. So if you can understand this, then you're sorted. Okay, so that's your notation. The next thing they talk about is roots. And please, I want you to realize roots will become more prevalent when you're in grade 11. But what they're talking about when they say roots is solutions, or we did mention it earlier, your x-intercepts. Okay, so notice if it turns on the x-axis, then there's only one x-intercept. If it doesn't touch the x-axis and it carries on up above here, there's no x-intercepts, and otherwise you will have 2 x-intercepts. So knowing the shapes of your graphs help with this when they're asking about roots or x-intercepts or solutions. Understanding your shape is important there. And then lastly, your transformation of graphs. And then there's an example which we're not going to go through. We're going to practice questions and memos. So we've got nice practice time. So it says reflection in the x-axis. Realize if you're reflecting the x-axis, your y value becomes negative. And that's for the equation as well. So for example, I'm going to just do number 1 as an example. If my original equation is y equals x squared plus 5, and then I'm reflecting in the x-axis. They said that to reflect in the x-axis, your y value, which you can actually imagine, here's my x-axis. If I had a point up here and I reflect it over, Do you see the X value actually stays in exactly the same place? It's the same X value, but my Y was positive, then my Y was negative. So it's something that you can imagine to try and remember so you don't make silly mistakes. So my Y value is going to become negative. So I literally make my Y value negative in my equation. But now if they want the equation, they want it in standard form, which means your Y value has to be on its own. So I'm going to divide everything by that negative, and I get Y is equal to negative X squared minus 5. Okay, so that's if I'm reflecting over the X axis. Okay. Any questions on the applications, or will we come across those when, because then I think there's an example. Let's just, sorry, I did just do the one example. Reflection, the Y-axis, the X value will change sign. In both axes, you change the sign of both of them. And then a horizontal translation, you add in at the end, so that Q value is going to change at the end of your equation. Okay, so that's your transformations of graphs. If there's any questions now, please ask, but I can imagine they'll actually come up when we are doing the practice. So there is an example, but we're not going to work through it. So let's go to our questions and memos. Let's finish the question that we were busy with. Now they're asking about our f of x and y of x and f decreasing. Okay, so the first one they've said is they want to know when f of x is greater than 0. But please take note, the start of the question says for which values of x is. Okay, so do you see they've asked you for the answer in terms of x, but the question is in terms when y is greater than 0. So we go back up here. We're looking at the graph of f. Okay, so we're looking at the graph of f, so that is the parabola, and we want to know where the y value for the f graph is greater than 0. Y is positive on top of, so it's this section of the graph here. You can either highlight the graph, guys, I'm highlighting it so you know which section I'm looking at, but it's this entire section. Actually, I prefer to highlight the graph, so I'm just going to stick to the graph. Okay, it's that entire section of the parabola that is above the x-axis. They're asking where is it greater than 0. Now that I've checked which section it is, so I've looked at where my y's are positive, you now need to answer your question in terms of x. So you're going to go to the very left-hand side. Remember, your x values is like your domain. Okay, so you go to the very left-hand side, your smallest value to your biggest value. And my smallest value here for x, remember I'm replying in terms of x. Yes, sorry, thank you. I see some people, I'm so busy trying to make sure. We go from the left-hand side to the right-hand side in our x values. So yes, thank you, Faith. Thank you, Dimple. Thank you, Emma. Okay, it's going from -2 to 2. And you'll notice that they have not included it. So we're going to use round or square brackets. Y element, we're going from -2 to 2, always the biggest values, round or small brackets. Okay, I've only got 3 people still with me in the session. Just Faith, Emma, and Dimple. Are the rest of you still out there? Give me a thumbs up. Okay. Great. Okay, so we do have some other people there. Are we all happy with this? Because I do know that this is something that even my matrics struggle with. Okay, great. Thanks, guys. Okay, is there anybody who's a little bit confused or has a question about this one where they said where f of x is greater than 0, and then my answer lands up being y, sorry, and I've said y. And that happens where x is an element from -2 to 2. It's okay to have questions on it. Okay. The next one, they're also still asking about F, but they're asking where F is decreasing. So I'm going to go back up to the graph. Remember, from left to right, you can see you start by going up, but then after that turning point, I start going down. So I'm just using a different color. So that is the section where I'm going down. Okay, now that I've figured out which section it is, we look at the X values for that section. Okay, so that's the part that's decreasing. So you start on your very left. It's from the X value over here. Please, I know there's a big fat 4 staring at you in the face. But what is the X value there? So you go and you read the X value. And then this carries on, remember, to infinity and beyond. It's getting wider and wider and wider. So yes, Faith, Dimple, Emma. Okay. They definitely got this section. So here we're going to say X element of, we're starting on the left, 0 to infinity. Then we need to make sure we use the correct brackets. Now, I see that you guys did use round brackets for the 0. Some textbooks say square brackets, and because of that debate, I want you to realize that both would be accepted. Okay, so I don't want you to stress too much. The 0, if you do science, it makes sense that the 0 is stationary. It's not increasing or decreasing. So then we would exclude it. So you would land up going from 0 with a round bracket, and then remember, infinity always gets a round bracket. You can also say X greater than 0. Sorry. Okay, I was asked, when do you use square brackets? So for example, in the previous question, if they had asked f of x greater or equal to 0, because of the equal sign, we would have used square brackets. Okay. For decreasing and increasing, they actually accept both. Okay, so that is, I suppose it's because it's up for debate, but for me, technically, it should be round. And yeah, it's more the inequality at this stage in grade 10 that will tell you whether you include it or not. So the little equal sign means you're going to use the square bracket, and the not equal sign is a round bracket. Okay. Asymptotes will always get round brackets, whereas turning points would get a square bracket if we're talking about a range, that sort of thing. But we will be practicing, so hopefully we'll get more comfortable with that. Okay, let's have a look at question 4.2. This time we don't have pictures to look at, so we're going to be probably sketching them. It says given f of x equal to and g of x equal to. First of all, tell me what type of graphs these are. So the first one, the blue one, F. Remember, we've got a straight line, a parabola, an exponential, or a hyperbola. So there's 4 different ones. That first one, which one is it going to be? Sure, and straight away, I've got 3 different answers. And this is why we need to go through them. Okay, so I'm just, before we do that, I'm going to the side and we are going to look at our different graphs and what the equations look like. So the first one we've got is linear, or your straight line. Okay, the next one we did, I'm doing them in the same order as the notes, parabola, or your quadratic. Okay, the next one is the hyperbola. And the next one is the exponential. Your standard form for all of these, y equals mx plus c. So these were all there in our notes. The parabola was y equals ax squared plus q. Your hyperbola, y equals a over x plus q. And your exponential, y equals a times b to the power of x plus q. And I'm now going to highlight the things that tells you what type of graph it's got. The parabola has an x to the power of 2. The hyperbola has the x in the denominator. The exponential has the x in the exponent. And the linear just has something multiplied by the x. There's nothing else special happening. Okay, that's the 4 different things. And you should be able to look at the equation and see what type of graph it is. So if there's just something being multiplied by the x, we know it's linear. If the x is getting squared, it is a parabola. Hyperbola, the x is underneath. And exponential, the x is in the exponent. So I'm going to ask my question again. The question that I underlined in blue, the equation I underlined in blue, the F graph, is it linear, straight line, or hyperbola? Or parabola, sorry. Okay, linear, thanks. That's definitely a better response. If you're still uncertain why it's linear, please let me know. Okay, because I can tell when you guys, I get more information from you when you guys know what we're doing, and all of a sudden you guys become quiet when you're not sure. And I'd rather you ask, because then I can find out what you don't understand. Okay, so we know it's linear. Let's look at the next one. I'm going to underline that one in green. Okay, so G graph, which type of graph is it? Remember, we've got 4 different types. Okay, great. Majority of you have got it right. It is exponential because the x is in the exponent. Okay, please be aware there's something difference between 2 to the x and x squared. They are not the same thing. Okay, so the x squared, this would be a parabola, but that guy there is exponential. Are we all happy with that? Okay, it says write down the equation of the asymptote of G. Okay, so this is your learning work. Guys, it's exponential. We've only got 1 asymptote. 2 asymptotes belong to hyperbola. And always remember, it's that beautiful Q value. Okay, so I've got an answer from Emma. Okay, they asked for an equation. Make sure you give it to me in the format of an equation. It will be a horizontal line. Brilliant. Kapotso, Dimpo, Lamise, great. Y equals -1. I know I missed some of your names, but brilliant. Y equals -1. Okay, next question. It says sketch the graph in F and G on the same set of axes using the diagram sheet. Let's see, do that. Have they given us a diagram sheet? No. Okay. So we are going to sketch it just on our own set of axes. So if we want to sketch the graphs, we need to know what they look like. Okay, so let's start with the F1. You guys already told me that it was linear. Is it going to be going up or down? Is it increasing or decreasing? Okay, up. Brilliant. Well done, Natalia, Faith, Emma, Kapotso, great. So that's my one graph. It's going to look like that. The second graph is exponential. So remember your exponential graph, you've got different shapes. You've got an asymptote going across. I'm not drawing my x-axis in. It can either be going increasing above or decreasing above. And then if there's a negative right in front, you'd flip those over and then it would either be decreasing or increasing. So let's first tell me, is it above the asymptote or below the asymptote? Is this graph going to be above the asymptote or below the asymptote? Kapotso, Emma, Faith, Lamise, yes. Okay, it's going to be above the asymptote. Now that we know it's above the asymptote, I'm going to delete those guys. It can't be either of those. Okay. Now tell me, is it the increasing one or is it the decreasing one? And guys, remember, if you don't know the answer, telling me what you think it is or saying I don't know is part of me being able to help you. Okay, great. Thank you, Faith, Lamise, Emma, Komotso. Thank you, everybody who's participating. Sona Sifo. Okay, guys, it is the increasing one. And how do we tell it's the increasing one? So it's this one on the left. as you look at the number at the base of the exponent. And if it's bigger than 1, it's going to carry on multiplying and carry on getting bigger. Okay, so bigger than 1. So that is exactly what you're going to do there. So that's what my graphs are going to look like. Now that we know our graphs are going to look like that, we are going to calculate everything we need. Okay, so first of all, for the F1, I know it's increasing. So I'm going to calculate y-intercepts and x-intercepts. Okay, how do we get our y-intercept? Make x equal to 0. So I'm going to go y is equal to 1/2 times 0 plus 2. Guys, I'm hoping a lot of you could have just looked at the equation and straight away known that it was going to be y equals 2. For the x-intercept, how do we find your x-intercept? y0. So what is the x-intercept going to be? All of you work it out for me, please. Work out your x-intercept for me, please. Be careful of your signs. Great. Okay, so that's my y-intercept and my x-intercept for my straight line. I know the shape, I know the intercepts. That's all I need for a straight line. There's no asymptotes. There aren't any turning points, anything funny like that. Okay. For the graph of G, we've already got that the asymptote is y equals -1. That was our very first question. Okay. We know that it's going to be increasing. The first thing we're going to now work out is whether we've got any y-intercepts or x-intercepts. Okay. This -1 tells me that it's moved down. So it is actually going to cross the x-axis. So I'm going to have a y-intercept and an x-intercept. We'll start with our y-intercept. You guys said make x equal to 0. So all of you, please work out your y-intercept. Everybody work out your y-intercept for G. So for our y-intercept, remember we make x equal to 0. Work out your y-intercept for G. Okay, so I've got lots of answers, not all the correct ones. So I'm going to show you all the working out for that. So my y-intercept, we make x equal to 0. Oh, yeah, so not all the right answers. So we've got y equals 2 to the power of 0 minus 1. Remember, anything to the power of 0 becomes a 1. So that's going to be 1 minus 1. And that gives me 0. Okay, guys, this gives me the point 0, 0. So do you see that it's actually also my x-intercept? Okay, so I'm not going to bother trying to work out my x-intercept because I'm going to get exactly the same point, because that's also where y is 0. So it says sketch the graph of f and g on the same set of axes using the diagram on the last, and it says label all relevant points. Do you see that didn't ask for anything extra? So I'm not going to use my table method here. So we are going to now draw a y-axis and an x-axis, and we're going to put in all our relevant information. Okay, so starting with the straight line, my relevant stuff, my x at -4. Use a good scale. You don't have to measure out every single value. Y equals 2. And you guys are going to use a ruler, and you're going to draw your straight line. And that was for F. Okay, the next one, my asymptote was relevant. So at -1, I'm going to put a dotted line going all the way across, and you label it. Okay, I know I've got an intercept at the point 0, 0. And this is where your shape is important, because look, I don't know any other points, but I can just draw my curve now. I know that it's going to be approaching that asymptote, not touching, and then it gets very steep very quickly. That would get you all your marks, sorry, and label that one G. Guys, if you are stressed out that you don't know how steep to go, then please, by all means, use your table method. But I want you to realize that all this working out that we did on the side, that's not what gets you your marks. Marking this, there would maybe be a mark for each x-intercept for the straight line. But I'd say probably for your intercepts, both being correct, and for a straight line. You would get a mark for your asymptote, a mark for your intercept, and a mark for the shape of G, which means you've got the curve going steep. It doesn't have to be exact. It has to look exponential. So it can't touch the asymptote, and it's got to get steeper and increase. Okay. That's where the marks are allocated to. So doing a table is not going to get you marks unless they've asked for extra points. Okay. Any questions on that? Now is the time to ask, but otherwise that is our graph. And now it says, using your graph, write down the coordinates of one point of intersection of F and G in the first quadrant. Okay, so they're looking for the coordinates of that point over there. How could we go about getting that point of intersection? How do we get that point of intersection? Yeah, so this is a question to everybody. How do we, yes, absolutely, Faith. Yes, Dimple. Yes, Kapotso. Okay, so they did say using your graphs. So remember, they actually originally gave a diagram sheet, so you would have had a more accurate graph on your diagram sheet. We are going to solve them simultaneously so we can actually calculate it. Okay. My guess is it's probably at 1 or something similar. Okay, so let's have a look. We've got our equations. We are going to now solve simultaneously. Equate formula 1 to the other. Yes. Okay, brilliant. Okay, so we've got our two equations, a half x plus 2 has to be equal to 2 to the x minus 1. This is one that's going to be difficult for us to solve because we've got an exponential and we've got something there. So we're going to have to fiddle and use a little bit of intuition. That's one of the reasons why they said using your graph. And it's also one of the reasons why it's only 2 marks. Okay, so the first thing I'm going to do is I'm going to add 2 on both sides. Okay. And then you'll see here that we might get a little bit stuck. So I'm going to do a little bit of a trial and error. We know we have to be in the first quadrant. Okay, I can see my y value is going to, ma'am, don't you subtract 2? Oh, thank you. Apologies, I appreciate that. We subtract 2 and we get -3. Okay, thank you, Emma, for spotting my mistake. Okay, and we are going to now try and find a point where these guys are going to cross. So my estimation is, if I have a look here, it looks like it might be around about a 1 or a 2. Okay, so we're going to use our graph to help us because we cannot solve this equation. That's why it said use your graph. So we're going to test stuff. So I'm going to test x equal to 1. As I say, I'm sorry, my sketch is very rough and they gave you a Cartesian plane in the test. So it would have been a little bit easier. And the minute I want to test x equal to 1, I see I'm going to get a fraction. So I'm kind of not keen on that. So I'm going to cross that out. And I'm going to test x equals 2 because it looks more like a 2 on my graph here. So I go a half times 2 and I get 1. And then I go 2 to the power of 2 minus 3, and I get 1 as well. So I know that that is exactly where it's going to be, where my x value is 2, my y value is going to be 1, which means I'm definitely off of scale for my curve. Oh, sorry. That's why. It's not at that spot. Apologies. We're going to substitute in there. We're going to have a half times 2 plus 2, which is going to give me 3. That makes a lot more sense. 2 to the power of 2 minus 1. That also gives me 3. Sure. Okay, I'm definitely tired, you guys. And it's because you guys are making me do all the talking. I'm going to blame you. You guys have broad shoulders. Is that okay? Sorry, I made things a little bit more confusing than I needed to be. Guys, as I said, you would have had a more accurate drawing because they had given you a Cartesian plane in the test. Tell me if there's anything that's unhappy there, because I wouldn't be surprised because I was all over the place. Isn't it -3? Okay, no, if I go half times 2, so first of all, it has to be in the first quadrant. So in the first quadrant, they're definitely asking where everything is positive. Do you see in this section, your x and y values are positive? And second of all, if I go half times 2, I would have got 1 plus 2 there, which is a positive 3. And here I would have got 4 minus 1. So I hope you're okay that that's going to give you a positive 3. And I see what you were asking about the -3. Earlier, I did the moving the 2 over. And moving the 2 over, yes, would have given me a -3. But then I was actually using the wrong equations then. So I'm going to keep the equations as they were originally. And that's what I was substituting into. Okay, sorry, Kapor. So that's totally my fault because I started in one method and realized, wait a second, they asked you to use the graph. So I should have stopped doing that method straight away. Okay, great. Okay. Okay, guys, let's look at the next one. Write down the equation of h of x. Okay, write down the equation of h of x. If it is the reflection of g along the y-axis. So if I reflect something over the y-axis, tell me, guys, what's going to change if I reflect something over the y-axis? If I reflect something over the y-axis, imagine it. And how's it going to change? Okay, so I'm not getting to the equation yet. Okay, so if I've got my y-axis here and I reflect something over, do you see the y value is staying the same, but my x value is going to change sign. So what happens here is my x value changes sign. So that is exactly what we do. We're going to take the equation for g of x and we're going to change the sign of x. Okay, so we're going to take the equation of g of x and we're going to change the sign for x. Beautiful notation, Stephen. I love it. So many people hate that notation and you've used it so beautifully there. Okay. Guys, so I'm going to take the equation for g and I'm going to go back to y's and x's, but you're more than welcome to do fancy stuff. I'll show you now. Okay, so I'm going to have y equals 2 to the x value changes sign minus 1. Now, the way they've asked the question, guys, that is your answer. Done. And I don't know why I wrote it in purple, because I circled the question in green. Okay. Okay, that is the equation done. You do not have to do anything else. They haven't asked for a specific format, so this is for question 4. You're more than welcome to just say then h of x, because they called it h of x. is equal to 2 to the negative x minus 1. Okay, but I want to remind you some of the algebra that we learned on Monday, because they can be a little bit mean. They could have said in the form of, and g of x equals b to the power of x plus q. That means they want the x to be positive. Okay, so I want you guys to have a look. If I've got a negative exponent, what do I have to do to change that exponent to a positive exponent? Okay, so be careful. It did change. The x value became a negative. So it's not the same as the equation I got it before. Yes, you're going to make it a fraction. This is exactly the same as I changed that 2 to a half, and then all of a sudden the exponent is positive. So they could have asked it for in that format. So it would be a half to the power of x minus 1. So do you see it is actually a different equation, because our first one was increasing, but if here my base is a half, do you agree that that would have been a decreasing graph for the h? Okay. Are we okay that it has changed? Natalia, are we good with this? Great. Okay, going back to now number 5. What is the range of f? I'm the Lone Ranger. This is my domain. They're asking about the range. So they're asking about all the y values. Go from smallest to biggest. Remember, your y values are smallest at the bottom, and they're asking about f. So I'm going to my graph. The f is the blue line. As low as it can go. Remember, there's arrows. To the highest it's going to go. What is your answer for the range of f? For the range of f. Okay, so remember your graph is going down here. It's the blue one. Down to negative infinity, and then this arrow is going up, so it's going to carry on going up to positive infinity. So I see a lot of you desperately trying to get numbers. There are a couple of ways that you could have written this. Okay, the quickest way is say y element of all reals, because it's literally everything. It's the straight line. It's going to go down forever and up forever. Okay. That's the quick way to write it. Or you could have written y element from negative infinity to positive infinity. Okay, those are your options for writing the range for f. Please let me know, because I got lots of different answers. I got from -4s and I got from 2s. Please make sure you're looking at your blue graph or the correct graph when you're answering the question. Okay, so it wasn't the green one. And I know there's a 2 here, but do you see it goes lower than 2? All of that part, it's underneath the 2. I know there's a -4, but do you see it goes lower than that even? And on top of it, the -4 is an x value. Okay. So I hope you guys are okay with why it's going to be absolutely everything. If you're still unhappy, please let me know. And then this one that everybody doesn't like, or that I'm used to people not liking, determine the values of x for which f of x times g of x is greater than 0. So this greater than 0 says they're looking for where it's going to be positive. Okay, if I multiply two numbers and I want it to be positive, what has to happen? If I multiply two numbers and I want them to be positive, what do we know about the signs of those two numbers? What do we know about the signs of those two numbers? They have to be the same. They're either going to be negative or both positive. So we're going to look for where they're both underneath or both on top of the x-axis. So we're looking at the blue and the green graph together, both underneath or both on top. So where would they both be underneath? Do you agree from this section? Okay, and I know I haven't drawn my green graph there, but that section there, they would both be underneath the x-axis. and then they'd both be on top of the x-axis for this section here. Okay. Okay, that's where they're both negative, and then where they're both positive. So that means if I multiply them, I will get a positive answer. Hope we're all good with that. Now I need to answer that in terms of x. So remember, your x values are going across. So let's start with the first section. Okay. What are the x values for this very first section here that I've highlighted? X element from the smallest value, as far left as those graphs are going to go. And then up to the x value where it stops. Brilliant. Okay, so negative infinity to -4, infinity always gets a round bracket. Now we need to pay attention to whether we're putting a square bracket or a round bracket for the -4. Okay, so I know that's a question that you often ask. So let's go and double check. They said that it can be equal to 0. Okay, it has to be positive or equal to 0. And at this point at -4, it's going to be equal to 0, but it's allowed. So the square bracket. Okay, that's the first section. Or the second section. What is the smallest x value for that second section that I've highlighted? And then what is the biggest x value for that second section? Yes, Nazar. Yes, Faith. Yes, Emma. Brilliant. Yes, Dimple. 0 to infinity. Okay, infinity always gets a round bracket. Then we've got to check, are we including the 0? Do we get a square bracket for that 0? Well, at that point, it's going to be equal to 0, and that is allowed. So we include it. Okay, square bracket. Are you guys happy? I could start the whole new question. But we've only got 4 more minutes. So I want to know, is there any specific question that you guys have? Otherwise, I'm going to find another of these inequality type questions, because I honestly feel like that's where I'm picking up you guys are not answering as much. So I'm assuming it's because you don't know. Okay, so any specific questions quickly before we sign off? Otherwise, I'm going to do another one of these with the inequality. Okay. No unmuting, no questions coming through. Okay. So we are going to have a look. Okay, we're going to have a look at question 4.4 quickly. So Nasipo, are you wanting to ask a question? Okay, I'm going to look at 4.4 quick. They talk about h of x, which is not in the original question, so we're just going to have to quickly get that. They said determine, okay, no worries, okay. They said determine the equation of g of x, so that you're asking for this equation over here. And then they said equation h, the axis of symmetry of g, which has a positive gradient. Okay, so I'm going to draw that in for you. There is an asymptote here. So your axis of symmetry is going to be going through there. Okay, and that is going to be your h. So we know the gradient of that guy is going to be 1. Because it's the positive. Remember, the gradient for your axis of symmetry is always 1 or -1. So it's 1x. And then you can see your y-intercept where it crosses the asymptote is going to also be at 1. So that's the equation of that straight line. Okay. Now we can answer these questions here. Use the graphs to determine the values of x for which g of x is equal to h of x. Okay, so we're looking for where they're going to be equal. And they did say use the graphs. I think I've drawn this sort of accurately enough. So it looks like that's going to be at the point 2 and 3. And this is not a very good drawn point. It looks like it's going to possibly be -1 as your y value and -2. I think that's supposed to be a -2 and 1. Okay, if you'd used your ruler, sorry, -2 and -1. Okay, but what I want to focus on is this one. They want to know where g of x is less than h of x. So where the g is underneath the h. Okay, so let's go back here. Where is g underneath h? So do you agree g is underneath h in this whole section there? And in that section there. This is our last question. Okay. But then they added something extra. They said they want to know this part of it where x is less than 0. So do you see that on the right-hand side here, my x is greater than 0. So they're asking about this section on the left. So I'm going to undo that highlighting. I want you guys to have a look at that, those x values based on the coordinate that I gave you there, the -2, 1, which I think is correct. Okay, based on that coordinate, -2, -1, what are the x values for what I've highlighted? It's going to be x element, the x values from the very left to the very right. Last question, I promise. I want all of you to tell me. From the very left to the very right. Okay, yes, Emma, yes, Stephen. Yes, Nazar. Okay, remember, Nazar, you're looking at your x values. So you got part of it right. Same Dimple, part of it right. Your very left is -2. That's where everybody's getting it right. Remember the very right-hand side of what I've highlighted, it's not going to go past this line, and I'm looking for my x values. The x value there, I know it's going down forever, but the x value is at 0. Okay, so it's actually going to go up to 0, but it'll never touch because of that asymptote. So that will get a round bracket. Then if we look at the question, do you see that they were allowed to be equal to each other? So the -2, which is where they're equal, that is allowed, that will get a square bracket.